Welcome to another screencast in the iMath Tutor screencast series. I'm Dr. Regis J. Sorinko, founder of iMath Tutor. The title of today's screencast is Blue Eyes, the hardest logic puzzle in the world. Now, we've seen various versions of the blue-eyed logic puzzle in many places over the years. The first time we encountered this was in a homework problem that was assigned for Penn State's Math 311W course. That's discrete mathematics, introduction to proof course. And we saw a version of this problem there. We've also seen it in a number of places over the internet over the years. The statement we give here comes from the creator of the Excited XCD cartoon. You can see the link to the statement at the bottom of the slide if you want to go see their statement. So let's get moving and give a statement of the problem, which, and by the way, the idea that this is the hardest logic puzzle in the world comes from that cartoon. We're not sure if that's actually true. So we have a group of people with assorted eye colors that live on an island. They're all perfect logicians. If a conclusion can be logically deduced, they will do it instantly. No one knows the color of their eyes. Every night at midnight, a ferry stops at the island. Any islander who's figured out the color of their own eyes then leaves the island and the rest stay. Everyone can see everyone else at all times and keeps account of the number of people they see with each eye color, excluding themselves, but they cannot otherwise communicate. Everyone on the island knows all the rules in this paragraph. On this island, there are 100 blue-eyed people, 100 brown-eyed people, and the guru. She happens to have green eyes. So any given blue-eyed person sees 100 people with brown eyes, 99 people with blue eyes, and 1 with green eyes. But they do not tell him or her his own eye color. As far as he knows, the total could be 101 brown and 99 blue, or 100 brown, 99 blue, and he could have red eyes. The guru is allowed to speak once, let's say at noon, on one day in all of their endless years on the island. Standing before the islanders, she says the following: I can see someone who has blue eyes. Who leaves the island and on what night? Now, our solution uses mathematical induction on a number of blue-eyed islanders. The base case of 1 blue-eyed islander and the next case of 2 blue-eyed islanders are worked out. This is enough for the pattern to become obvious. The induction hypothesis is then proposed. The induction proof is completed. Some preliminaries are taken care of before the induction proof is started. We'll let capital N denote the number of blue-eyed islanders. We'll let capital X the number of blue-eyed people seen by a blue-eyed islander, and Y the number of blue-eyed people seen by a non-blue-eyed islander. Clearly, blue-eyed islanders see 1 less blue-eyed person than there are, and the non-blue-eyed people see exactly the number of blue-eyed islanders. So X equals N minus 1 and Y equals N. So let's take a look at the state of knowledge for the 2 classes of islanders, that is the blue-eyed and the non-blue-eyed. Blue-eyed islanders, before the guru's announcement, these islanders know the following: that if their eyes aren't blue, then the number of blue-eyed islanders are just the number that they see, X, And if their eyes are blue, then the number of blue-eyed islanders are the number of blue-eyed islanders they see plus themselves, so n equals x plus 1. Before the guru's announcement, these islanders know the following. If their eyes aren't blue, then the number of blue-eyed islanders they see are the number of blue-eyed islanders, so n equals y. If their eyes are blue, then the number of blue-eyed islanders are the number they see y plus themselves, so n equals y plus 1. So let's move to the base case where there's a single blue-eyed islander on this particular island. In this case, the number of blue-eyed islanders that blue-eyed islander sees is 0, and the number of blue-eyed islanders that the non-blue-eyed islanders see is 1. So let's state the state of knowledge for the two classes of islanders. Before the guru makes an announcement for the blue-eyed islanders, if their eyes aren't blue, then there are no blue-eyed islanders. If their eyes are blue, then there's only one blue-eyed islander, and that's them. Before the guru's announcement, these islanders know that if their eyes aren't blue, then n equals 1, and if their eyes are blue, then n equals 2. So at noon, the guru announces that n is greater than or equal to 1. That's essentially what I see one blue-eyed islander means. After the guru's announcement, these islanders know that n equals 1. Therefore, they must have blue eyes. After the guru's announcement, these islanders know that n equals 1 or n equals 2. This is exactly what they knew before the announcement, so they know nothing more. The guru's announcement carries nothing new, no new information for them. So these islanders don't know their eye color after the announcement. So we're still looking at the base case. What happens? Who leaves the island and when? The blue-eyed islander boards the ferry and leaves the island the first midnight after the announcement. Clearly, as soon as the announcement is made, they know their eye color and they leave at the first possibility. Each of the non-blue-eyed islanders knows that if their eye colors were blue, that the blue-eyed islander that they saw would have the same information that they have. Hence, the blue-eyed person these non-blue-eyed people saw would not have deduced their eye color and boarded the ferry. Consequently, the non-blue-eyed islanders conclude upon the departure of the blue-eyed islander that their eyes are not blue. But since eye color is not binary on the island, that is not enough to tell them what their eye color is. So the non-blue-eyed islanders do not learn their eye color and do not leave the island. Now let's move on to the next case where there are two islanders with blue eyes. In this case, the number of blue-eyed islanders that each blue-eyed islander sees is 1, and the number of blue-eyed islanders that each non-blue-eyed islander sees is 2. The state of knowledge for the two classes of islanders, in this case, before the guru's announcement, these islanders know the following. If their eyes aren't blue, then n equals 1, and if their eyes are blue, then n equals 2. Before the guru's announcement, these islanders know the following. If their eyes aren't blue, then n equals 2. If their eyes are blue, then n equals 3. When the guru announces that n is greater than or equal to 1, how does the state of knowledge for these two classes of islanders change? The state of for both classes of islanders, the state of knowledge hasn't changed, because for both of them, they already know that n is greater than or equal to 1. So at the first midnight following the announcement, no one leaves because at this point, no one knows their eye color. For the Blueeyed Islanders, remember n equals 1 or 2. These islanders each reason that if n equals 1, then the blue-eyed person they see would have deduced their eye color after the guru's announcement and left the island at the first midnight after the announcement. Since no one left the island at the first midnight, these islanders know that n equals 2, which can only be true if their eye color is blue. Who leaves the island and when? Both Blue-eyed Islanders leave the island at the second midnight following the guru's announcement, because now they've deduced their own eye colors. Each of the non-Blue-eyed Islanders know that if their eyes were blue, that the Blue-eyed Islanders that they saw would have the same information as they have. Hence, these blue-eyed persons, these non-blue-eyed people saw, could not have deduced their eye color and boarded the ferry on the second midnight after the announcement. Consequently, the non-blue-eyed Islanders conclude upon the departure of the blue-eyed Islanders that their eyes are not blue. And again, eye color is not binary, so knowing that your eyes are not blue is not sufficient to know your eye color. So these non-blue-eyed Islanders do not learn their eye color and do not leave the island. I think we're now in a position to state our induction hypothesis. If there are k blue-eyed Islanders, then these Islanders board the ferry and leave the island at the kth midnight after the guru's announcement. Let's look at the induction step and suppose now that we have k plus 1 blue-eyed Islanders. In this case, the blue-eyed Islanders see k blue-eyed Islanders, and the non-blue-eyed Islanders see all of the blue-eyed Islanders, so there's k plus 1. Now let's look at the state of knowledge for the two classes of Islanders. Before the guru's announcement, these Islanders know the following. If their eyes aren't blue, then the number of blue-eyed Islanders is k. If their eyes are blue, then the number of blue-eyed Islanders is k plus 1, the k they see plus themselves. Before the guru's announcement, the non-blue-eyed Islanders know the following. If their eyes aren't blue, then their number of blue-eyed Islanders are k plus 1. This is the number that they see. And if their eyes are blue, in addition to those k plus 1, you have to add in themselves, so that the number would be k plus 2. Now, the guru announces that n is greater than or equal to 1. For the blue-eyed Islanders, n equals k, or n equals k plus 1. After the announcement, each of these Islanders conclude from the induction hypothesis that the blue-eyed people they see leave the island, that if the blue-eyed people they see leave the island at the kth midnight after the announcement, that their eyes are not blue. When the blue-eyed people that each of these Islanders sees fails to depart on the kth midnight after the announcement, these Islanders know that their eyes are blue. Who leaves the island and when? The blue-eyed Islanders leave the island at the k plus first midnight after the guru's announcement. Each of the non-blue-eyed Islanders knows that if their eyes were blue, that the blue-eyed Islanders that they saw would have the same information as they have. Hence, the blue-eyed people these non-blue-eyed people saw could not have deduced their eye colors and boarded the ferry. Consequently, the non-blue-eyed Islanders conclude upon the departure of the blue-eyed Islanders that their eyes are not blue. And again, because eye color is not binary, the non-blue-eyed Islanders do not learn their eye color and do not leave the island. So let's go on now to what happens on the island, where you have 100 blue-eyed people, 100 brown-eyed people, and a guru with green eyes. We have that the blue-eyed Islanders leave the island at the 100th midnight after the guru announces that there is at least one blue-eyed person on the island, and no one leaves the island, no one else leaves the island because no one else will figure out their eye color. Thanks. That's it. That's the hardest logic puzzle in the world. Is really, in our estimation, not that difficult once you decide to use induction. And the key here is that for induction to work, you have to be able to prove the base case. And without the guru's announcement, you could not prove the base case. And that's what the guru's announcement allows to happen, is it allows the proof of the base case and therefore allows induction to be done on this problem. So thanks for watching, and now a word from our sponsor. iMathTutor offers face-to-face tutoring for university students and professionals that can meet with us in State College, Pennsylvania, online tutoring for university students and professionals worldwide, and we also sell quick reference guides and practice exams with detailed solution sets for Penn State Math 141. This is the second semester of Calculus with Analytic Geometry. These are distributed by Nittany Notes, so if you're interested in them, visit the Nittany Notes website at www.nittanynotes.com. Study material for other courses will be added as demand dictates. To learn more about tutoring and to arrange a free consultation, visit us at https://imathtutor.org, or you can email or call us. Our email is help@imathtutor.org, and our phone number is 814-317-6284. Again, thanks for watching, and stay tuned for more screencasts to come.